Hello everyone. Welcome to our physics classroom. This is your teacher Ren, happy to be with you as we explore the world of physics. Do you happen to wonder why airplanes can fly? This will be our
This is a
discussion for
demonstration
today.
of Wirecast.
Daniel Bernoulli is a Swiss mathematician and scientist who was born in the 1700s and who is most famous for his work in fluid pressure. This is Daniel Bernoulli.
This is a demonstration of Wirecast.
But before that, let's try to recall some important facts. First, we have to remember that air is a gas, and at the same time, we consider it as a fluid. Next, air pressure is due to the motion of its particles. And last,
This
pressure
is a
is equal to the
demonstration of
force per
Wirecast.
unit area. So what do you think will happen if there is a quicker stream of particles that travel? What will happen to its pressure? Any guess? Yes, you are correct. Whenever there is a quicker stream of particles to travel, we expect that there is less pressure.
This is a demonstration of Wirecast.
Bernoulli's principle now can be expressed in this manner, that whenever there is a streamlined flow, the pressure of a fluid decreases as the velocity increases, and the pressure increases as the velocity decreases. Also, we can state it that whenever pressure in a moving stream is less than the pressure in the air surrounding the moving stream.
This is a demonstration of Wirecast.
Let's try to look at this illustration. The arrows on top of an object signify what we call signifies as greater air velocity, while under the object we can have it as less velocity. On top, due
This
to
is
the
a
many
demonstration
arrows,
of
there is
Wirecast.
now what we call as a quick stream. Thus, it will give us low air pressure. And below the object, we have it as a low stream, meaning there is high air pressure. Remember that the flow of ideal fluid is governed by the two equations. First is what we call the continuity equation, which is area 1 times velocity
This
1
is a
is equal to
demonstration of
area 2 times
Wirecast.
velocity 2. And second equation is on Bernoulli's equation, telling us that the product of pressure times the mass divided by its density plus the product of mass times the square of its velocity divided by 2 plus the product of mass times the gravity and times its height will give us actually what we call as the pressure head, the velocity
This is
head,
a
and the
demonstration of
elevation head.
Wirecast.
So the sum of all these three heads are the same at any point of a particular flow of a fluid. We can apply this in this particular problem. Water is flowing through a pipe of varying
This
cross-section
is a
and
demonstration of
elevations.
Wirecast.
At point 1 of the pipe, the cross-sectional area is 0.75 square meter. The velocity is 6 meters per second, and the elevation is 3.5 meters. At another point, the velocity is 2.5 meters per second and the elevation is 1.5 meters. Find the cross-sectional area at point 2 and the pressure difference at points 1 and 2.
This is a demonstration of Wirecast.
In solution, we have to specify first what are the given quantities. We have our area 1, which is 0.75 square meter, the velocity 1, which is 6 meters per second, the height 1 is equal to 3.5 meters, velocity 2 is 2.5 meters per second, and height 2 is equal to 1.5
This is a
meters.
demonstration
We
of
are asked to
Wirecast.
determine the area 2 and the pressure difference between the 2 points. In solving for our area 2, we are going to use the continuity equation. Thus, in finding area 2, we will have the product of area 1 times velocity 1 divided by our velocity 2. So, after substitution, we can now have an area 2 which is equal to 1.8 meters per second.
This is a demonstration of Wirecast.
In finding the pressure difference between 2 points, we are going to use the Bernoulli's equation. By substitution, we are now going to arrive at a pressure difference which is equal to 10,150 pascals.
This is a demonstration of Wirecast.
Wonder how there is a standing tennis ball? Let's find out. Imagine that this is a tennis ball which is suspended on air. Why does it stand in the air? So let's assume that airflow is equal under the tennis ball.
This is a demonstration of Wirecast.
This airflow is equally divided to all sides of the tennis ball. So there is what we call as the stream of equal speed, thus there is equal pressure. The downward force is what we call the G, or
This
the
is a
force due to
demonstration of
gravity.
Wirecast.
Thus the ball stands on air. The air pressure below is equal with the G force. Thus, that is the very reason why we can have a standing tennis ball. How about the
This is a
physics in flying?
demonstration of Wirecast.
We all know that there are many devices that operate in using the Bernoulli's equation. Among them are the sprayer, air pump, vacuum pump, and the Gordon gauge, which is used for measuring very high pressure. But the most significant of this is the airplane. Let us relate now Bernoulli's principle and the flight of
This is a
airplanes.
demonstration of Wirecast.
It is a fact that Bernoulli's principle is what allows birds and planes to fly. And the secret behind flight is what we call under the wings. Remember the song, Wind Beneath My Wings. Consider this as a cross-section of an
This is a
airplane wing.
demonstration of Wirecast.
Air is going to flow on one side, and on top of the wing of an airplane, you can find a quicker stream of air. So the air on top of the wing must travel a longer distance than the air below the wing. But air on both sides must reach the end of the wing at the same time. Therefore, the air on top of the wing traveling faster
This is a
will give
demonstration
us
of
less air
Wirecast.
pressure. This will now create what we call as the lift. Below is an illustration of how are we going to compare the surface pressure when exerted on surface areas of the wing. Is this plane ascending or descending?
This is a demonstration of Wirecast.
You can see in the pressure guide below or under the wing that blue is having the lowest pressure or air pressure and red is having the highest air pressure. So in the cross-section of the airplane's wing, we can see that the air pressure is highest below the wing of an airplane.
This is a demonstration of Wirecast.
It shows now regions of air pressure around specific areas of the wing. Again, notice that the low pressure region is above the wing, allowing for upward thrust. So what is now your answer? Is the plane ascending or descending? Of course, the plane is ascending.
This is a demonstration of Wirecast.
The cross-section of the wing of an airplane, its shape causes air to flow over the top surface faster than under the surface. Where velocity is faster, pressure is lesser. The greater pressure under the surface accounts for about two-thirds of the lift on the wing.
This is a demonstration of Wirecast.
So there are actually four forces that are acting on the flight of an airplane. First is what we call the thrust. Next, we have the lift. Then we have the gravity. And last is the drag. Where do all these forces come from?
This is a demonstration of Wirecast.
The wings now provide the lift, the gravity provides the g-force, and fluid friction provides the drag. The engines provide the thrust. What is happening if the airplane is
This is a
flying at
demonstration
constant
of
altitude?
Wirecast.
What forces are involved? And yes, if the airplane is going to fly at constant altitude, the forces that are involved are the following. First, we have what we call the lift, and another is the thrust.
This is a demonstration of
Okay,
Wirecast.
everybody, let's try to have this problem exercise. Let's apply Bernoulli's principle, Bernoulli's equation, and the continuity equation in answering this exercise. When a horizontal pipe of cross-sectional area, 8.6 squared centimeters, has a constriction of cross-sectional area of 2.6 squared centimeters, water is flowing through the pipe at a speed of 3.5 meters per second
This
where
is a
the pressure is
demonstration of
70
Wirecast.
centimeters of mercury. Find the speed and the pressure in the constriction. I'll be giving you 5 minutes to do this problem exercise. Okay, done with our problem exercise. Let us now have our activity. Group yourselves according to your grouping of
This is a
specialization.
demonstration of
We have our
Wirecast.
business group, we have our art group, and we have our science group. Using Bernoulli's principle, design a paper airplane that will stay in the air the longest period of time, or will have the longest distance traveled. You will be divided into groups of three that will represent a diversity of specialization. You will produce a product that represents your own group. The materials
This
and
is a
equipment are the
demonstration of
following.
Wirecast.
Three sheets of 8 1/2 by inches by 11 inches recycled copy paper. Each group will be given three pieces of 4-inch long adhesive tape, one stopwatch to time the length of flight, and assign a student who will serve as a plane retriever. Your product will be rated based on the following rubrics. With category,
This
first,
is a
we have the
demonstration of
information gathering.
Wirecast.
Second, we have the construction of materials. Third, we have data collection. Fourth, we have the function. And fifth, we have the modification of fifth, we have the modification of your product. So this will be your guide in building your paper airplane. So during our next meeting, we will have to
This is a
test your
demonstration
paper
of
airplane.
Wirecast.
So let's remember how Bernoulli had given us so much to think about. Thank you for Daniel Bernoulli for helping us understand the things that we are actually enjoying this time, and of course, the joy of going from one place to another by riding through an airplane. So once again, this is your
This
teacher,
is a
and thank
demonstration
you
of
for being with
Wirecast.
me, and hope to see you in our next discussions. Thank you very much.